Hi everyone, welcome back to my number sense series. In this video, we're going to be talking about a very special base, a base called binary or base 2. Now, we humans think and operate in base 10, but computers especially find it very easy to operate in base 2 because base 2 can be very easily represented physically using on and off switches, light and dark, things like that. So it's very important to understand what base 2 is, especially if you're planning to study computer science or take a computer science class in the future. They absolutely expect you to be familiar with base 2, 4, 8, and 16 especially. So let's take a look at these numbers I've written down. 0, 1, 10, 11, 100, 101, 110, 111, and 1000. If you didn't look at the base, if you're thinking about these as base 10 numbers, it would look like I am just listing random numbers. But if you think about this as base 2, you might figure out that I am actually counting. This is 0, 1, 2, 3, 4, 5, 6, 7, and 8 in base 2. But how does that even make sense, right? Let's think about how to count in base 2. Well, first of all, 0, no problem with that, right? 0, universal number, 0. Then let's add 1 to 0, okay? 0 plus 1, you got a 1. And we are allowed to write 1 in base 2. It'd be very sad if we couldn't because then we'd all have zeros. But since in base 2, 1 is the largest digit we're allowed to write, so nothing wrong with that, 1. But what happens if we try to add another 1? What is 1 plus 1 equal to? 1 plus 1. Now, normally you would write 2 because 1 plus 1 equals 2, but this is base 2. Just like how we can't have 10 in one digit in base 10, we can't write 9 in base 9, we can't write 2 in base 2. So what do? You have to write 1, 0. Just like how if we were doing 1 plus 9 in base 10, this also has to be a 2-digit number because 10 is too big of a number to contain in one digit, right? So it has to be 0 here and then it overflows into the next digit, right? You carry here. 1 plus 1, 2 is too big, so this becomes a 0 and this also carries into the next digit as a 1. Okay, then what's 1, 0 plus 1? Well, 1 plus 1, 0. 1 plus 0 is 1. No big deal here. 1 isn't getting added to anything, so it's 1, 1. Then what happens if we do 1, 1 plus 1? Once again, we have this issue of overflow, of carrying, right? 1 plus 1 equals 2. Well, we can't write 2, so we have to write 0 and then carry this 1 over. But then in this column, we have also 1 plus 1. And we can't write 2 again, so we have to do another 0 and then carry that 1 over into the final column where there's nothing there. So we have to write 1, 0, 0. And in this way, we get 4. And you can verify that this is 4 because this has a place value of 1, 2, 4. 4 times 1 is 4. Then it proceeds very similarly, 101, 110, 111, and on our last number, 111 plus 1, something very similar happens, this kind of domino effect, where we get 0, 0, another 0, and then finally a 1 to make 8. Now, hopefully that made sense, but if it didn't, let's get a little bit more practice with base 2 addition in our next problem. 1, 0, 1, 1, base 2, plus 1, 0, 0, 1. Okay, let's just do column addition like we learned in elementary school. 1 plus 1, what's that? 1 plus 1 is 2, but once again, we can't write 2. So what can we do? We have to carry into the next digit. Just like, once again, if I add 1 plus 9 here, I can't write 10. I have to write 0 and then carry 1. So 1 plus 1 equals 0, carry the 1. Now, again in this column, we have 1 plus 1. Well, what's 1 plus 1? It's 2, but we can't write 2, so we have to write 0 and carry over here. So then we carry a 1 over here. 1 plus 0 plus 0, no problem with that. It's just 1. We can write that. But then over here, once again, we have 1 plus 1, and we can't write 2, so let's write 0, carry the 1, get 1, 0, 1, 0, 0. And you can confirm this by converting this to base 10. You get 11 and 9, which makes 20, and this is 20 in base 2, if you wanted to confirm that way. So let me fix that. 1, 0, 1, 0, 0. So hopefully that made sense. But if it didn't, really just keep on practicing because adding in base 2 isn't a super important skill in number sense, but it's definitely good for training your understanding and just, mental facilities. But I think a more important concept is how to convert from other bases into base 2. This is important not only for number sense, but also if you plan to, ever take a computer science class, like I said, you have to know how to do this. So what is 21 base 10 in base 2? Well, it's going to be just like us doing, converting to base 5 or 3 or 6 or 7, like in the other video. But this time with 2, we have probably more place values, more digits. Because think about the powers of 2. It goes 1, 2, 4, 8, 16. We can have a 16 here. So we have actually 5 digits already just from a small number like 21. So 16, 8, 4, 2, 1. But notice this time, there's not really an idea of how many of each digit fits into here, right? Because it's either a 1 or a 0. It's yes or no this fits. So it becomes a little bit easier in base 2 in a sense. So really, let's just think about it. 16 fits? Yes. 1. 1 is yes. So then after we put a 16 here, what values do we have left? It's 21 minus 16, so we have 5 left to allocate between these. 8 goes into 5? No. So we write a 0. 4 goes into 5? Yes. So we write a 1. Then after we subtract 4, what value do we have left? 1. 2 goes into 1? No. 1 goes into 1? Yes. So our answer is 1, 0, 1, 0, 1. So really, it's just going down the list of powers and saying, okay, does this fit? Yes, write a 1, subtract. No, write a 0, go to the next digit. That's really it. So, let's just try it again in 89. So 89, once again, is a bigger number. And here we're going to have even more digits. How many digits? Well, 1, 2, 4, 8, 16, 32, 64. 64 is the biggest power of 2 less than 89. So we're going to have this. And you don't have to write this, and in fact you can't, because this has to be all done in your head, but this is what I kind of imagine going on in my head when I'm doing this conversion. So 64 goes into 89. Of course, the first digit always has to go into it, because if it didn't, we just remove it. So this goes into it, yep. Then what do we have left? 89 minus 64, we have 25 left. 32 goes into 25, nope. 16 goes into 25, yep. So we subtract 16, and we have 9 left. Then 8 goes into 9, yes, barely. And it leaves us with 1. And at this point, we can just kind of skip to the end, because 1, we know what to do with 1. 0, 0, everything is 0 except our last 1. So to convert 89 into base 2, we write 1, 0, 1, 1, 0, 0, 1. And once again, that comes from going down the list of our powers of 2 and seeing if they fit or not. And once we get, 1 at the end, we can just skip to the end and say, okay, everything else is a 0, and we have a 1. 1, 0, 1, 1, 0, 0, 1. Nice. Now our last question is an interesting question. I especially made this question to test an idea. Now, of course, you can do this question the normal way. So let's do it the normal way first, right? Okay, what can we fit in here? We can fit a 1, a 2, a 4, an 8, a 16, and a 32, but not a 64. But as you notice, 63 is really close to 64, and that fact might come in handy later. But let's forget about that for now. What we have is 32, 16, 8, 4, 2, and 1. Does 32 go into 63? Yep. So 63 minus 32 is 31. So we have 31 left. Does 16 go into 31? Yep. So after that, we have 15 left. Does 8 go into 15? Yep. After that, we have 7 left. Does 4 go into 7? Yep. Does 2 go into 3? Yep. And, we have 1 left. And, of course, 1 goes into 1. So our answer somehow is 1, 1, 1, 1, 1, 1. And you might be saying, wow, that's crazy. How can we have predicted that we've ended up with a 1, 1, 1, 1, 1, 1? But it's not really crazy. And here's the answer why, okay? 1, 1, 1, 1, 1, 1. Don't think of it as 1 more than 0. Think of it instead as 1 less than 2. That is the really important thing that we have to realize here. Instead of, okay, let's try to imagine like a base 10 equivalent of this. Would it be 1, 1, 1, 1, 1, 1 in base 10? No. Think about it as 9, 9, 9, 9, 9, 9, okay? This 1 is 1 less than 2, the biggest allowed digit. It's not an allowed digit. 1 is the biggest allowed digit, and you're filling a number with them. Similarly, in base 10, 9 is the biggest allowed digit. Think about 9999999. Well, that's obviously just a million minus 1, right? Well, then this is just a million minus 1, but a million in base 2, kind of. This is 1, 0, 0, 0, 0, 0, 0, minus 1. Just like how this is 1, 0, 0, 0, 0, 0, 0, minus 1. Because these are both all the biggest allowed digits in that base. This is full of 9s, and this is full of 1s. That is how they're similar. So this is 1, 0, 0, 0, 0, 0, 0, minus 1. What's this in base 2? That would be the next place value, 64. This is 64 minus 1, because 64 is 1, 0, 0, 0, 0, 0, 0 in base 2, because it's a perfect power of 2. So when I gave you 63, instead of doing this, you could have said 63 is 64 minus 1, which is 1, 0, 0, 0, 0, 0, 0, minus 1, which is 1, 1, 1, 1, 1, 1. And there's nothing wrong with doing this method, nothing at all, but I think understanding the relationship between 63 and 64, just like understanding the relationship between 99 and 100, is something really, really important and trains your base to really think in base 2, not just think in base 10 converting to base 2. So this is an introduction to binary. This is our video that will cover, what binary is, how to add a little bit in binary, maybe even subtract, how to convert numbers in base 10 to binary. In the next videos, we're going to cover how to convert between, base 2 and base 8, base 4 and base 2, things like that. And those are actually based on special exponential properties that I'll cover in those videos. But for now, hopefully this video makes sense to you because it is pretty important basics. So yeah, that's going to be it for this video. Thank you guys for watching, and I'll see you next time.